Welcome to the first video for Measurement and Math for Science. This video will explain the MKS system and the difference between basic and derived units within the MKS system. First of all, what we normally call the metric system is known internationally as System International or the SI system. And in any measurement system, whether it be metric or English, there are 7 basic quantities to define. The first, and not in any particular order, is that we must measure length. And in the SI system, length is always measured in meters, and the meter has the symbol M. And later we'll talk about prefixes that we can add out in front of the M to either multiply or make the base unit smaller. But length is the first quantity that must be defined, along with mass, and the unit of mass in SI is the kilogram, abbreviated SG. The third one that goes together, and they're a little bit out of order here, but time is the next one that is defined, and that is measured in seconds. So when we're doing calculations in class, the majority of the time, if the quantity of time is given in hours or minutes or days, those quantities must be converted into seconds in order to maintain consistency within the system. These 3 quantities comprise the first semester of the course, and by the time we get to second semester we will define temperature, measured in a unit called Kelvin. If you've had chemistry, you will know the relationship between Kelvin and degrees Celsius. And then if you've also had chemistry, you will know that the amount of substances are kept track of in a unit called the mole. We will not be dealing with that in physics, but we will in chemistry. And finally, the 2 last items that need to be defined in a measurement system are electric current, measured in amps. We'll get to that second semester as well. And luminous intensity. How bright is light that we're looking at, and that's measured in a unit called the candela. These are considered the 7 base units of SI or the metric system. Any other unit is a derived unit. So how do you know if we're dealing with a base unit? They're one of these 7. How do we know if it's a derived unit? It's everything else. Let me show you what I mean by a derived unit. Here we have 3 measurement systems laid out next to each other, and the one that we will deal with primarily in physics is metric or SI, and it's the MKS system. And in the MKS system, that stands for meters, kilograms, and seconds. All of our units will be derived from, primarily, meters, kilograms, and seconds. And here we see length, mass, and time are the meter, the kilogram, and the seconds. And so within the metric system, there is an alternative that makes use of centimeters, grams, and seconds. We won't be dealing with this. The CGS system is sort of outdated, and the preferred metric system is the MKS system. So what do we mean by a derived unit? A derived unit, here we have length that's measured in meters, and we know that. That's a basic unit. Mass is a kilogram. That is also a basic unit. And now when we take a quantity like velocity, where we have distance divided by time, we simply take the appropriate and I forgot to mention time, which is up here in seconds. When we get to something like velocity, which is considered a derived unit, it's a combination of 2 or more of the basic units. And so here we have distance divided by time is in meters per second. And so we can see that these are 2 of the basic units combined mathematically to create what's called a derived unit. Here we have again acceleration, which is velocity divided by time, which is meters per second over seconds. which equals meters per second squared. If you don't quite understand that, that's okay. What I do want you to see is by looking at this, we can see meters are here, seconds are down here, and so once again, this is a derived unit. We'll be getting to force this semester, F equals ma. You've probably heard that before. And if we take mass times units of acceleration, we get a unit called the Newton. And how do we know that Newton is a derived unit? Well, first of all, we can see that it involves kilograms, meters, and seconds, so we know that that's derived. And we know that Newton does not appear on this list, so therefore Newton must be a derived unit. And some of the other more common units that we're going to be dealing with this year are the joule and the watt and the Newton second, the Newton meter, and all of these are derived units because they come from the base units or some combination of the base units. If you would like more information on this topic, I would suggest doing an internet search for SI units, metric system, or base and derived units. You'll turn up lots of nice information. I would like to say that all 7 of these quantities have very defined, well-defined definitions. So a meter has a very well-defined meaning, as does a kilogram, a second, and so forth. So we're not going to cover that right now, but if you're interested, you can easily look up what the standards are for each of these quantities of measurement. Make sure that if you have any questions over this topic, you ask me in class. Thank you and good luck.